Okay, so with rational exponents, we no longer are looking for pairs of twos. We are looking for groups of things. So what tells us we're looking for groups of things? So you need to rewrite it. Okay, so we're going to rewrite it with the nth root of b to the m. What you're going to want to do first is you're going to want to apply this exponent first and then the nth root. This n tells us the groups we're looking for. So if it had a 4, we're looking for groups of 4. If it had a 5, we're looking for groups of 5. So let's practice. So here's example number 3, letter A, 16 to the 1/4. I'm going to do my reverse rule here. Okay, so I'm going to rewrite it as the 4th root of 16 to the first power. Well, I know 16 to the first power is just 16. Typically, we'd be looking for groups of 2. But because there's a 4 in my index, I'm looking for groups of 4. So I'm going to break it down just like I did before. I'm going to break this down into 2 and 8, 2 and 4, and then 2 and 2. So I did my prime factorization tree, and I'm looking for groups of 4. So instead of circling the 2's and these 2's, you're going to do the group of 4. Now this group of 4 is allowed to come out of the radical now as just a 2. So your answer to letter A here is just 2. Okay, we're going to practice on letter B again. So the first thing you need to do is the reverse rule. I'm going to write it below it. So I have the 3rd root of 27 squared. So I'm going to apply my exponent first here and still take my 3rd root. 3rd root of, well, 27 squared is 729. You're going to break it down just like we did before. Okay. I'm going to start with 9. I'm going to try to find the highest number I can bring out to see if I can find my groups of 3. So here I'm going to do 9, and then it breaks down into 81, and then 9 and 9. So my grouping here, I need 3 of them to be able to come out and rewrite it as a single unit. So here's my group of 3. Okay, so the answer to 27 to the 2/3 is just 9. Again, one huge thing is that this number here, the index, we're looking for the groups of that. And over here, we're looking for groups of 3.